Hello everyone, welcome back to most frequently asked viva questions in RDBMS Part 2. If at all if you are watching this video directly, make sure that you watch Part 1 video also. Now let us get started. The next question, what are the various keys in a database? These are all the various types of keys that you can have in a database: primary key, candidate key, super key, composite key, and foreign key. Now, what is a primary key? A primary key is that column in a table which is used to uniquely identify every record in the table. So, for example, let us take student table. In student table, assume that maybe 100 students are there. Now, how do you differentiate one student from other student in this student table? There should be some mechanism using which the records in this table can be identified uniquely. So that is possible with the help of a column called as primary key column or primary key field. Now, primary key field makes sure that every record in the table is identified uniquely. The best example for primary key column in a student table can be student roll number. No two students will have the same roll number. So if there are 100 students in the class, 100 students will have different roll numbers. Hence, we can take this roll number column or field as a primary key field or primary key column. And also note that primary key column will not allow null values in the primary key column. So what is a null value? Null value is neither zero nor it is spaces. Null means empty. Null means empty, neither zero nor spaces. Next, what is a candidate key? A candidate key is a key or a set of keys which uniquely identifies every record in the table. Now, the definition looks similar to the primary key, but there is a slight difference. So, when I talk about candidate keys, primary key, just now we have discussed that primary key is used to identify every record in a table uniquely. Now, example for primary key that I have given was roll number. Now, is there any other column in the table using which you can identify different students in the table uniquely? Yes, if at all assume that there is a column called as Aadhaar number. Now, students can be identified based on their roll number as well as their Aadhaar numbers. So, this roll number and Aadhaar numbers are called as candidate keys. So, what can you conclude from this? You can conclude that a table can have more than one candidate keys. Out of these available candidate keys, one key should be selected as a primary key. So in our example, if you're taking roll number and Aadhaar keys as the candidate keys, right? So out of these two, we have to select one of them as the primary key. Okay. So a table can have only one primary key. A table can have more than one candidate keys. That's what we have seen. Candidate keys can be many, but primary key will be always one. From the available candidate keys, one key has to be selected, and that key will act as a primary key. Now, what is a super key? A super key is a set of keys which contains a primary key along with the combination of other non-key fields. For example, roll number. Okay, just now we have seen roll number can act as a primary key. So, along with roll number, if at all if I am taking a combination of roll number and name, still it will identify students uniquely, all the records in the student table uniquely. I can take a combination of roll number and age, right? It will again identify all the students uniquely. I can take a combination of roll number with course, and like this I can have n number of combinations. So all such set of keys are called as super keys. All such set of keys are called as super keys. All these can uniquely identify records in the table. The only reason being, what is common in all of this? The column that is common in all of these keys is your roll number. Since roll number alone is sufficient to identify different records uniquely, so all these combinations also will identify records uniquely. So such set of keys are called as super keys. Next, what is a composite key? Now assume there is no primary key column in a table. I mean to say that there is no column in a table which can act as the primary key. So if that is the case, we will take a combination of non-key columns, okay, columns which are not primary keys, okay. So such non-key columns will take their combinations, and that combination will act as a composite key. So that combination will act as a primary key. Again I repeat, if there is no column which can act as a primary key in a table, then we'll take help of non-key columns, we'll take their combinations, using which you can identify every record in the table uniquely. So that is what is called as a composite key. Next is, what is a foreign key? A foreign key is used to establish relationship between two tables. Now you can see here from this example, there are two tables. The first table I can call it as student details table. The second table I can call it as course table. Now, what is the primary key and what is foreign key in this table? Now, you have to make sure that there is a common column between these two tables. In order to establish a primary key foreign key relationship, you have to make sure that there is a column which is common in both these tables. So as per these two tables, now you can see the common column here is CID, which I am calling it as course ID. So course ID is acting as primary key in the course table, and the same course ID is acting as foreign key, okay, in the student details table, right? So that's what the definition is telling. A foreign key is used to establish relationship between two tables. A primary key of one table will become the foreign key of another table. Like primary key in this student details table is acting as foreign key in the the primary key in this course table is acting as foreign key in the student details table. Now, what are the necessary conditions to implement a primary key foreign key relationship? Just now we have seen, in order to implement a primary key foreign key relationship between the two tables, there should be a common column between the two tables. That's what we have seen in the previous example. The common column is course ID. Course ID in the course table and course ID in the student details table. So don't get confused. This table is, I can call this table as student details table. STD DET. This is the first table, and this is called as second table, which I can call it as course details table. Course table or course details table, right? Next one, what are the necessary conditions to implement a primary key foreign key? That we have already seen just now. And next question is, what is the use of a database index? Okay, why do you use a database index? Database index is used to speed up the search process in a database. For example, assume there are 10 lakh records. There are 10 lakh records, right? So out of these 10 lakh records, you are searching records satisfying a certain criteria. Okay, then you will take help of database index. Okay, database index is similar to a textbook index. What is the use of a textbook index? Index in a textbook. Okay, you search for a particular topic, find out the page number, and directly you can go to that page number, right? Likewise, a database index is used to speed up the search process in the database. Next one, what is an ER diagram? ER diagram stands for entity relationship diagram. ER diagram represents the logical design of the database. Okay, ER diagram represents the logical design of the database. Like, what do you mean by logical design? Logical design means, what are the tables, what are the relationships, what are the attributes in every table, and all these things. Okay, which is the primary key and all these things. So this is what is called as logical design. So an ER diagram is used to represent the logical design of the database. Now, what are the various symbols which are used in an ER diagram? So these are the various types of symbols which are used in an ER diagram. This is an ellipse. Okay, ellipse stands for an attribute. An attribute is represented using an ellipse symbol. An entity is represented using a rectangle symbol. A relationship is represented using a diamond symbol. A multi-valued attribute is represented using two ellipses, and a key attribute. Okay, what is the difference between normal attribute and a key attribute, a primary key attribute? Now you can see that it is underlined. Okay, it is underlined, right? And you can see two rectangles here. This is a symbol which is used to represent a weak entity. So what is the difference? Entities can be of two types. One is a strong entity and the other is a weak entity. I repeat, entities can be of two types. One is a strong entity and the other is a weak entity. A strong entity is an entity which has a primary key in it. Okay, a weak entity is an entity which doesn't have a primary key. Next is, who is a DBA? Okay, question when be asked, who is a DBA? DBA stands for database administrator. DBA plays an important role in every organization. DBA is responsible for maintaining and organizing data in the database, right? And these are some of the functions of DBA, like installing the database, configuring the database, okay, generating the database design, and monitoring the performance of the database, taking care of security, also taking backup and recovery. Next question is, what do you mean by database integrity? Okay, database integrity refers to the validity and the consistency of stored data in the database. So it is referring to validity and also consistency, okay, of stored data in the database. Now, what are the various types of integrity constraints? Okay, integrity constraints are classified into domain integrity constraints, entity integrity constraints, referential integrity constraints, and key integrity constraints. So these are the constraints. What do you mean by a constraint? Actually, constraint means a condition. Okay, constraints means a condition. Okay, now what is the use of this integrity constraints? If someone asks you, okay, then these integrity constraints are making sure that whatever data we are entering inside the database is valid and also consistent. Okay, so integrity constraints make sure that whatever data you are entering into the database is valid and also constant. Okay, I mean consistent, right? Next question, what are the various types of file organizations? Now these are the various types of file organizations: sequential file organization, index file organization, indexed sequential file organizations, heap file organization, and hashed file organization. Someone asked you, what do you mean by file organization? Okay, the way file organization is referring to the way or manner in which your records are arranged in the database and how you are accessing these records. So all those concepts will come under your file organization. For example, if you are using sequential file organization, in this type of organization, the records are stored in a sequential manner. That is one record after another record, right? And if 10 records are there, for example, assume, then if you want to access fifth record, then you'll have to start right from the beginning. That is from your first record, move to the second, third, fourth, and finally you'll come to the fifth record. Okay, so that is what is called as sequential file organization. Index file organization. Okay, here you'll maintain a separate index file, which is a small file using which the records are arranged in a file. Likewise, you have index sequential. Index sequential supports two types of access. One is indexed access, that is accessing the records to the index, and also sequential. Both ways are allowed. Next, you have heap file organization, which is also called as unordered file organization. Here, records are stored randomly. There is no particular order or sequence in which the records are stored. That is your heap file organization. Next is hashed file organization. Okay, hashed file organization is used to what you call speed up. Okay, if you want to search any record directly, then you'll get an address called as hash address will be generated, based on which you can directly go to that address, right? That is what is called as hashed file organization. Next is, what are relational algebra operations? Okay, a relational operator takes one or more relations as input and returns single relation as the result. And these are the following list of relational algebra operations which are allowed: union, intersection, difference, Cartesian product, selection, projection, division, rename, assignment, and join. I will try to make a separate video. This is a lengthy concept. I'll try to make a separate video on this relational algebra operations. You can refer to that video. Now, what is a join? Okay, these things you people should be knowing. What is a join? Okay, how do you define a join? A join is used to retrieve data from more than one table. A join is used to retrieve data from more than one table. Whenever you are trying to retrieve data from multiple tables or more than one table, you use a concept called as join. Join operation is used to combine similar tuples from two relations into single relation. This is the other definition. A join is a combination of a Cartesian product followed by a selection process. Now, what are the various types of joins in DBMS? From DBMS perspective, there are basically two versions of joins. One is called as natural join, and the other is called as theta join. Now, when do you use a natural join? Natural join is used when there is at least one common attribute that exists between two relations, and that attribute should have the same name and domain. Whereas if you are going with theta join, in theta join we apply the condition on the input relations, and then only those selected rows are used in the cross product to be merged and included in the output. These now, what are these two joins you have seen? Natural join and theta join definitions you have seen. These are from DBMS perspective. Whereas if you are going with types of joins in SQL you have various other types of joins like equi-join is there, non-equi-join, outer join. In outer join, again, you have three types of joins. One is left outer join, right outer join, and full outer join. And also you have self join. What is Cartesian product? Okay, Cartesian product is also called as a cross product. It is a type of join in which rows of the first table are merged with all the rows of the second table. That means you take record in the first table, and with that record in the first table you take various combinations in the second table. You take second record in the first table, and then again you take various combinations in the second table, right? So like this, if first table is having maybe 5 records and second table is having 10 records, then how many records are you going to get? 5 into 10. 5 into 10, which is equal to 50 records. Okay, I repeat, if first table is having n records, second table is having m records, then after applying the Cartesian product, I'm going to get the output as 50 records. So take one record from first table, take all the combinations in the second table, like that, right? This joins is a very lengthy concept. If possible, I'll try to make a separate video extensively on this joins concept.